Tonight's speaker has been here several times before. Bill Cirillo. He's our spaceman. He's a member of the New Jersey Astronomical Association and the Space and Astronomy Club. Please welcome Paul Cirillo.
Thank you, Vince. Thank you. Thank you, Vince, and everybody. Thanks for having me. I don't like to stand behind podiums, so I'm going to stand up here, hopefully, and be okay. Well, while we're waiting for a slide to come up, the whole idea of my talks is to allow you to ask me questions. We're all busy with day-to-day activities. We go about our lives. We're in rooms. We're in communities. You have it actually running now? Okay. Is that in full screen? You have all that stuff on the top?
This is air traffic control. You're cleared for takeoff.
There we go. Okay. So I have a series of things to talk to you about, but by all means, at any time, if you have a question about what I'm talking about, raise your hand. Let's get it out of the way. I will leave time at the end, though, to have you ask me anything that you want with regard to astronomy or space exploration. Doesn't mean I know all the answers, but if I know the answer, I'll tell you. If I don't know the answer, I'll make something up. Okay? What's new in space and astronomy? That's a big, big thing. And the first question you probably have is, who the heck is Paul Cirillo? Well, even though I've been here before, let me just say I've just been interested in astronomy and space exploration ever since I can remember. I grew up in the 60s, and what was going on in the 60s but the space race. And so I was very interested in that. Heck, I remember Telstar, okay? I remember Echo. I remember seeing Echo balloon going around the Earth. So I've been watching this stuff for a long, long time. I belong to the largest public observatory in New Jersey. It's located in Highbridge, New Jersey. It's actually in Voorhees State Park. I'll have a slide at the end promoting that. We're open every Saturday night in the summertime. You're more than welcome to come up. We've had a couple of beautiful nights these past 2 nights, and that's a perfect time. If you can, hop in the car and come on up on a Saturday night. Just make sure it's not a full moon night, okay? Those are not good for observing. I also do some volunteer speaking for NASA's Jet Propulsion Laboratory. JPL are the people who build the probes that go out in the solar system and look at different things. And what they did is they found lots of people like me are out there who enjoy this stuff, but are not necessarily professionals. And so what we do is we join them once a month on a conference call. And we actually there's like 1,300 of us now in the United States. We actually get to listen and ask questions to the real scientists that are working hands-on with the space probes. So they fill us with all this information. They send us PowerPoints, and we go off mainly to schools, and the service is completely free. So if there's a school in the Somerset area or Somerset County area that you think might want me to come, even though it's summertime now, just get in contact with me. So that's me in a nutshell. Okay, so what's new with space and astronomy? Lots of things. This has been an amazing decade. There are some decades where it was really slow, but everything is happening this way. People are trying to get to the moon. We're exploring the planets. We have new rockets to take us into space. We have one fellow who wants to take everybody to Mars. We have another fellow who just wants to make money by sending people up and down in a little rocket. So a lot of things are going on. So I just picked a few things that I thought you might be interested in, and I'll just fire away here. But like I said, at the end, if you have any questions on anything, fire away. Okay, last time we were on the moon was in the late 60s, early 70s. 1972 was the last time we were on the moon. We had 6 missions that landed, so there were 12 people who walked on the moon. But we haven't been back since. That's a long time. It's over 50 years. So it wasn't until recently, well, actually it was about 10 years ago, that Congress decided, you know what, we really ought to get back to the moon. And no in Congress, they probably authorized it because they probably said, well, if we don't go, some other country is going to go, and then who knows what's going to happen. So they funded NASA to develop a program to get us back to the moon, and they call the program Artemis. All right. What's kind of cute about this is, anybody know the name of the program to get us to the moon back in the 60s? Begins with an A. Exactly. Apollo was a god, right? I think he was one of the head gods. Artemis is his twin sister. Isn't that cute? Kind of takes care of both things, helps with the equal opportunity, and we've got another goddess. So but NASA has developed something called Artemis, and the first thing they said is, well, we need a big rocket to get things into space. We used to have the Saturn V, but they stopped using that in the 70s. And then you hear all kinds of kooky stories like, now they've lost the plans to it. Nobody knows where the parts are. They can't make the parts. Who knows what the reason is? But just think of the leap in technology between the 70s and now. So they decided to start from scratch, which is what the government would normally do. And so they decided to start building a brand new rocket ship. And instead of giving it a classy name, they just call it the SLS, the Space Launch System. And that's because it can be used to send anything that can fit into it into space. So initially, of course, it's going to be people and cargo going to the moon. But it could go anywhere if somebody wants to fund it. It can go to Mars, it can go anywhere. So the SLS, or the Space Launch System, is what you're going to be hearing about. And they also needed to build a new human spacecraft to go along with it. Again, it was the Apollo spacecraft that was on top of the Saturn V. Now it's called Orion. And of course, it's newer, more modern. And what's nice is that it can hold 4 people now instead of just 3. And it's a lot more roomier inside, as you can see. So that's the human ship that's going to go along with the SOS. Now, it took a long time to build and develop the SLS. You know, anybody who's been in engineering or anything, when you start designing something new, it always takes you 3 times or 4 times longer than you thought it would, especially when it's new technology. So it took over 10 years for the engineers to get this to be as perfect as they could, did as many tests as they could, but they were very successful in their first launch, which was called Artemis 1. And so this is already back in 2022. That's a real picture of the first launch. It was not with people. It was with a mannequin, or whatever they call that, anthropomorphic dummy or something like that. But it was, the purpose of this test was just to test the hardware. And of course, some of the human engineering systems in the Orion, but mainly it was just to say, okay, we put this sucker together, will it work? And luckily, everything went fine. It took off on time, it completed its mission on time, and everything worked just fantastic. For those of you who are into space like I am, if what they did for this, by the way, which I thought was great, especially being the government, is they reuse stuff. What you see along the side of the SLS here, anybody recognize what those look like? SRB, solid rocket boosters, which were used on the space shuttle, right? So what they did is they extended them a little bit more. They put another section on top, but it's the same solid fuel rocket. So good for them. So they have those in the beginning. These engines, the 4 engines that are on the SLS, this is all fuel. Those are the same exact engines that they used on the space shuttle. In fact, some of them are the engines from the space shuttle. So that's nice. They saved us some tax dollars. They reused the engines and the SLS. Still cost about $1 billion to get this thing off the ground. Not $1 million, $1 billion. So it took off. It went off, I think, for 25 days. It went out where the moon is. It didn't orbit it, but it went out far, came back. And just like the old days from the 60s, it splashed down in the Atlantic. And this is a test with astronauts. There were no people, again, on board the actual launch there. So everything's pretty familiar. And again, very thankfully, it worked very well. All right, 25 days from November to December in 22. And you see it went out. It did loop once around the moon and then went farther out and did some gymnastics. And mainly, again, it was a hardware shakedown. And everything worked pretty well. I'm hearing now in the news that they're now looking at the heat shield on it, that they think there might be some imperfection on that. But by and by, it seems to be overall a success. So what's Artemis 2? Well, Artemis 2 is finally going to have people on it. It's going to have 4 people on it. And now the purpose of Artemis 2 is to test the human rating systems on board. So yes, there'll always be hardware, but now we got to see how does it handle people. And so it's going to take off from Earth, go around the moon a couple of times, and then come back. It's going to be a total of about 10 days. And that'll be interesting to watch. It's scheduled to launch in November, so it's not too far away. Hopefully they'll make it on time. If not, there's no big rush. We're not out to beat anybody this time, I hope. These are the people that they've selected already. They're already been selected and they're in training. After they complete their mission, and assuming all goes well, we will now go to Artemis 3. And Artemis 3 is now finally going to land somebody on the moon. And so it's right now scheduled for December of next year. And it's going to do just that. It's going to orbit the moon, land 2 people, stay there for a few days, do some exploring, testing some things out, and then head back to Earth. So it's several days there and back. So here we go, 30 days. I was looking for it. I knew it. So it's almost a month in space. And so hopefully that'll be a good shakedown. And then on we go to Artemis 4, 5, and 6. But right now, this is what's planned. So that's how we're going to go back to the moon. Yes, sir. Interesting you asked that. He just said, are they going to use a lunar lander, which was the LEM, like in Apollo? We'll watch the next slide. Okay, that's what they're thinking of using right now. What they did is, see, what NASA does now, which I think is really cool, is they send things out for bid. They say, look, we want to manage the whole space exploration thing for the US, but we don't have to have our contractors build everything. Maybe somebody can do something better. For example, right now, what's the name of the ship that takes our astronauts to the space station now? Anybody know? It's SpaceX, right? SpaceX, Elon Musk won that contract, and it's called the Dragon spacecraft. Excuse me, gentlemen. Boeing also got a contract to do it also years ago, and they finally just launched their Starliner. So we have Boeing and SpaceX taking our astronauts back and forth to the space station. Where before we had to rely on Russia to take us back and forth because we had no more space shuttle. But the question is now, okay, now what are we going to use? So there's no more LEM, lunar module. So what NASA said is, here's the requirements. They put out an RFP and they said, all right, this is what we want people to do, get to the moon, land the moon, come back. And they put it out for bid. And SpaceX won it. Now, Jeff Bezos, with his Blue Origin, but I'm not sure if he called that for the moon, but yes, Jeff Bezos was really mad about this because he couldn't get under Elon's price. But the thing is, look at the size of this sucker. This is Elon's, what he calls, very modestly, he calls his Starship. And he's building this huge thing to mainly go to Mars. But he said, while we're building it, we might as well take people to the moon. And so he got the contract to take the astronauts to the moon. Now, it's kind of a convoluted thing about the way they've got it planned. I'm not thrilled about this, but I'm not NASA. But instead of going directly to the moon, us and the European Space Agency and Canada and even and JAXA, the Japan Space Agency, we're going to all get together and build a mini space station that's going to orbit the moon, and they're calling it the Gateway. And so it's kind of like a stopover point before you go to the moon and back again. I guess somebody had the idea that Earth is 2.5 days away from the moon. And if something bad happens, that's a long time to wait for something. So they figured, let's have this gateway station here, and maybe that'll be a nice thing to have for safety. They're also thinking long term, which is good. And that is, if we ever do go to Mars and we need to build a new ship to do it, that might be a good place to do it. Build it in orbit and then take off from there rather than have everything come off the ground. Anybody see the movie The Martian with, what's his name? I forgot. Not Ben Affleck. Matt Damon, thank you. That was a really good movie. It was only a couple of flaws in it, but that was a really good movie. But do you remember how they got back and forth from Mars to Earth? The Hermes. They had a rocket called the Hermes. It was a big thing. It had even a gravity thing that was twisted, that was constantly turning. So they had some artificial gravity. And it would never land. It would just go back from Earth to Mars and back and forth. That's what we should do. We should build something like that in orbit and have it go back and forth instead of building all these big things and whatnot. And maybe that's what they're thinking of with the gateway, that maybe that's what we'll do and use the gateway to launch from. Okay, but that's the current plans right now for getting back to the moon. We'll watch it closely over the next couple of years, and maybe before the end of this decade, we'll actually have people walking around on the moon. We're not the only ones interested in the moon. The People's Republic of China is very, very interested in space. And they're government funded, so they don't have to cry to anybody to get money. They've got the full backing of their government. And they have a very, very formidable space fleet right now. Those are all the different kinds of rockets that they have there. They've been putting people into space in orbit. They've been sending satellites up. They even have some, I guess I have it right here. I'm jumping ahead. They even have a rover on Mars, and they even landed one on the far side of the moon. In fact, I think I just read that they collected a sample and they're starting to send it back. So they're very, very interested in space and being a leader in that area. Let me go back to where I was. So if you go to their website and look at what the China National Space Administration's goals are, here we go. Improve our standing in the world, establish a space station, go to the moon, establish a moon base, and robotic missions to Mars. Sounds pretty ambitious, and I don't doubt that they'll be working hard at that. As you know, we have an international space station. It's a big, big thing. It's as big as a football field. And it's nice that it was built with international cooperation. But in just a few short years, China put up their own space station called Tiangong. And there's a picture of what it should look like. And they now have 3. They don't call them astronauts. They call them taikonauts. That's what, we Russians have cosmonauts. We have astronauts. China has taikonauts. And they have 3 taikonauts on there at all times now. So they're moving right along, and just watch very carefully. Okay, that's all I'm going to say about getting back to the moon. I'm going to move on to some other things. James Webb is in the news like crazy. And what a fantastic telescope this is. James Webb was an early administrator for NASA, and he was brilliant at bringing NASA together and getting all the different departments focused on getting to the moon, because that was the mandate in the early 60s. And if anybody here has had to work with engineers and marketing, you know how that difficult it is to be in between. I was one of those people, and I used to have hair, so I know exactly what that's about. And that's what he was a master at. And so after all these years, they decided to name the telescope for him. So that's James Webb. Now, what's so special about this telescope is that it's using the infrared range of the spectrum. Now, we've probably all seen cops shows where, the perpetrators are running around in the woods at night, and they have a drone or a helicopter up, and they put their infrared down. And sure enough, you can see the poor fellas, hiding in a bush and whatnot, and they're detected. How do they do that? Well, heat happens to give off infrared radiation, but so does everything. And so do stars and planets. And so what they wanted to do is, they already had a telescope that can look at the visual like we do. It's called Hubble. And it's been up there now for almost, 30 years. And it's been sending us back beautiful, beautiful pictures of the galaxy and the cosmos. But they want to see farther. They want to go back farther and see what's out there. So they designed this to look primarily in the infrared spectrum, which is over here. And that was the whole purpose of, excuse me, of the Webb. And if you're not still sure what I'm talking about with infrared, this is a typical school problem where the science teacher puts his hand in a black trash bag, and then you turn on the infrared camera and you can see right through the trash bag and see his hand, and you can also see the heat given off by his body. Anybody here been a firefighter? Okay. Infrared goggles for the firefighters are amazing. Here's a firefighter looking into a smoke-filled room. Anybody in there puts on their infrared goggles, and there's somebody laying down right there so they can go save. So infrared has lots of applications, and it really is amazing. For some amazing technical reason, infrared waves go through dust particles better than visible light does. The explanation I keep reading is it's longer waves, and somehow that makes it go through. So it lets you see through dust and debris. So they designed this puppy. They launched it it's almost 2 years now. And what they did is they stationed it way out here past the moon. It's about a million US miles out there. And what they did is, since it's sensitive to heat, you want to get all the heat sources away because you want to see way, way out into the cosmos. So what are the three things that generate heat out in space when you're nearby? The sun, Earth, and the moon, right? So what they did is they put it way out here beyond the Earth and the moon. And so they try to keep the Earth, moon, and sun between the telescope and everything else. And so that's how they help protect themselves from the light from those sources. Here's one of the first pictures that came back. In astronomy, we know this affectionately as the Horsehead Nebula. And what a nebula is, it's gas and dust. Lots of gas and dust out in space. And when we say gas, it's molecular hydrogen usually, and a whole bunch of other things. But it actually can be so thick enough that it can blot out the stars behind it. It just happens to look like a horse head, and that's really nice. But that's visible light. That's what it looks like with Webb. With infrared, look how you can see right through it. Look how all the haze back here is gone. I'm going to flip it back again so you can see the difference. That's visible light. That's infrared. There are galaxies in here that you couldn't see before that you can see now. So that's just a quick example of how this thing works. You may, if you follow this stuff, this is actually part of what we call the Eagle Nebula. Again, more gas. But the news media got a hold of this picture. And since the scientists said stars are actually being made in these columns of dust, it takes billions of years, but stars are actually being made, somebody labeled this the birthplace of stars. And so that was in a lot of National Geographics and papers and whatnot. And now this is what it looks like in infrared. Look at that. The light comes right through it. They can see things. They can see far more stars and other things that are going on. So it's definitely living up to its name. And that's another thing. The darn thing is working perfectly. 1 second. Okay, but the darn thing is working perfectly. It had a lot of problems in development and whatnot. And in fact, when it took off from Earth, that telescope is as big as a tennis court. And what they did is they folded it up like origami, and they packed it into a nose cone of the biggest rocket at the time. And as it left Earth, and when it went out to that spot just past the moon, it slowly unfurled itself. Pyrotechnic bolts would blow, springs would start to unfurl it, and this whole thing, excuse me, gentlemen, I'm sorry, over 100 different functions had to happen to just get it to extend itself to look like what I showed you before. Everything worked perfectly. When they got it out there, it has actually 18 individual mirrors on it. They got them all to focus on a direct point, and it worked perfectly. Each of those 18 mirrors has actuators on it. So each one can be adjusted to hone the light. So it's just amazing. Scientists are giddy. They mainly look far out into the cosmos and toward almost the beginning of time. But they do every now and then get to turn it back on our own solar system. This is the planet Neptune, which is very hard to see from Earth because it's way, way out there. In fact, Voyager took this picture back in '89, and that was our first good shot at it there. And Hubble is the best Hubble can do from Earth orbit here. But when Webb took a look at it, again, it's looking at the infrared, so it's picking up heat. We knew Neptune had rings that were hard to see, but you can see Webb picks them up very easily. You can even see moons. Right in the rings is another one here, and you can see storms or some kind of weather system on Neptune here. So that's how it can pick up amazing things from where it is. This just came out. Uranus was again visited by Voyager in '86, and that's the exciting planet Uranus. When you look at it through a telescope, as I've had, it looks the same way, except small, but it just looks like a cue ball in space. Well, Webb just recently in December looked at it, and again, we knew it had rings, and also Uranus is kind of a funny planet. It actually got knocked over on its side way back. So it actually rolls around in its orbit, keeps one side toward the sun. And so it's just very, very strange. But it also has rings. And so the rings are again with its equator like that. So it almost looks like a bullseye orbiting around the sun. And that's why it looks like that when Webb looked at it. So there it is. There's Uranus, but in the middle, that's Uranus. And those are its rings, now brightly lit from the infrared. That's a close-up of it. And now you can see the individual lanes of the rings, which you could never see before in visual light. This is Uranus here, and that's what they think is like kind of like a frozen ice cap, a gigantic frozen ice cap, because it's really cold out there. And these here are some of its moons. It has a great many moons, and it could easily see that. I just want to point this out before I go, and that is, okay, this was the first wide-angle view of Uranus that they took. Can you see other things in this picture besides the moons? These are the moons right here. But can you see anything else? Yes, galaxies. Galaxies. It seems no matter where Webb points itself, it sees galaxies, which is truly amazing. Here's a galaxy right here. It's a galaxy very much like our own. Here's another one here. And I think I saw one up here before, but I can't see it on the screen. That's how busy space is, and that's how great the telescope is. Webb is making amazing discoveries every week. If you want to follow this, just put something like webnasa.gov in. You'll go to this site, and there is like a daily log of things that it's discovered. Good question. All right, good question. He asked, how do they determine the colors? Sadly, you have to understand one thing. All the color that you see in these pictures is not real. They add the colors. You can't get color from that great a distance. It just, you don't have the powerful, even these telescopes are not powerful enough to see color. So what some genius does someplace is they can see what light spectrum is being generated, and they actually assign colors to it. And then they use that throughout. So no, well, we hope it looks like that. And we hope Saturn looks like Saturn and Uranus looks like Uranus, but it's not 100% sure of what it is. They even do this with all these beautiful galaxy pictures that you see, even the nebulae I just showed you. It's all assigned colors, but they're really smart and hopefully they got it right. But yeah, it's not real. That's one of the things I often have to heartbreak parents when they come to the observatory, and they're very proud. They got this giant box and they just bought a $175 telescope for their youngster because they're going to be a scientist, and they wanted to do something nice for him. It's kind of sad because on the side of the box are all these pretty pictures of galaxies, Saturn, and everything, this big, and all these beautiful colors. And no matter $175, you think it's a lot of money. It's not when it comes to telescopes. They're very expensive instruments. And so even if you can get the thing set up and you go out in the backyard and you try to look at something, all you see are gray smudges. And so that's just the way it is. Our eyes are not going to be able to get enough light to receive color. So keep those dollars and do something else with it, okay? So I could spend a month talking to you about all the things that Webb has discovered and is working on. These are just 3 pages I took out of the log. Just look at the headlines. Webb opens new window on supernova science. Webb finds a plethora of carbon molecules along a young star. Galaxies actively forming in the early universe caught feeding on cold gas. Webb cracks the case of the inflated exoplanet. An exoplanet is a planet around other stars. Webb hints at possible atmosphere surrounding a rocky exoplanet. That got a lot of press recently because you know what they're all looking for? They're looking for Earth 2. Okay. How many science fiction movies have I seen with Earth 2 in it? Okay. So far, there's no Earth 2. There's no Earth 2 that we've seen. It's a big, big universe. Okay, I'm not going to read every one of these things, but here we go. Webb maps the weather on a planet 280 light years away. Just amazing, amazing things. And it goes on and on and on. So you can have a lot of fun just reading these things and seeing what's going on. What scientists do, by the way, is, nobody owns the telescope. It's government run. And so there's an institute in Virginia called the Space Telescope Institute, and a lot of smart people work there. But there's also a lot of smart scientists all around the world that want to use it. And so what they do, they have to apply for time on the telescope, just like anything else when you want to loan something. So they have to write a scientific paper explaining why their research is important. They submit it to the institute, it gets reviewed, and those that pass muster get time on the telescope. Then they do their research, and then they write another paper about what they found. And so papers are coming flying out of all the scientists that have anything to do with the Webb. And that's why it takes a little time for these amazing discoveries. But they're coming out, and it is truly, truly amazing. I've never seen anything work as well as this and produce so many amazing results. What planet is that? Nope. Mars, right? That's Mars. Anytime something's reddish, it's Mars. This is a picture taken of Mars when a probe is coming near it. And Mars has no water. It's all pretty much dust. And this is actually a giant crack that's in the side of Mars. That is as wide as the United States. And so that's a planet that's been in our science fiction lore and science books for a long, long time because it's very interesting. It's one of the closest planets to us, and so we want to study it. And again, we have lots of science fiction movies about the Martians coming here and what they look like and what they want. No Martians, so don't worry about that for now. But it is what scientists call the habitable zone. All right, from Venus to Mars, water can be liquid under the right conditions. And as far as we know, you need liquid water to have life. That's as far as we know. So Mars could have liquid water on its surface. Maybe not now, but in the past, it definitely had water on its surface. You can see gullies and riverbeds and lake beds on Mars now, all dried up. All the water is gone. So scientists are eager to find out, though, did life ever appear on Mars? And has probably died out now, or it's hiding somewhere. And they want to find that. They're curious because all life on Earth, be it plant or animal, is based on carbon and the molecule DNA. DNA. Everything has DNA. It's the way everything is built on Earth. So they want to find out, was life started maybe someplace else on a different way. And that would be a fascinating thing to study. So what they did way back in 2012, now this is what, 12 years ago, they landed a rover on Mars called Curiosity. And its whole sole purpose at that time was just to check the environment of Mars, check the soil, check the atmosphere, check the radiation levels, everything it could to see, could it have had the elements for life? So life could have possibly gotten started. And it was only there a month and it came back with a resounding yes. So for the last 12 years, it's just been tooling around, drilling samples in the soil and checking things out and having a good old time for itself. But its main mission of were the elements there for life to begin? And the answer is yes. Okay, so the next mission was go look for it. And so the next mission was called Perseverance. And that was just launched about 3 years ago. And it looks pretty much the same way. Once they get a rover to work, they kind of use the same body design. And this actually landed, pinpoint landing, in a dried up lake bed from Mars. And it was a water lake bed. Water's all gone. So this landed in the middle of that and started taking samples. It would drill down and then it would take a core sample that's within its body. And then as it went along, it would drop them to be picked up later. So there's a whole bunch of sample tubes on Mars just waiting to be picked up to bring back here. Why? Well, you can put whatever chemical analysis laboratory in this thing as you can. You can't beat the facilities here on Earth. So lots of planetary geologists and other kinds of scientists, they just can't wait to get their hands on real Martian soil, Martian regolith. We don't call it soil. And so Perseverance is doing that. Both of these craft are still working well, which is amazing. Curiosity's been there for 12 years. So that's my update for you on Mars. Curiosity and Perseverance are working well. Yes, sir. Yep. Excellent questions. I'm not going to answer them, but excellent question. Excellent questions. What he said is, when are they going to bring those samples back? And are we going to protect ourselves in case there's the green goblin inside one of those things? All actually excellent questions and very, very difficult that they're working on. So they came up with a plan and they called it the Mars Sample Return Mission. Well, it got complicated because it's not that easy to send something to Mars, land it, roll around on Mars, pick up samples, take off again, come back to Earth, then land on Earth. That's quite a tall order. So what they did is they got together with Europe. Again, Europe has a good space program. And so they called this whole thing the Mars Sample Return Mission, NASA with the European Space Agency. And they were going to land a vehicle that had a rover on it. It was going to rove around, find all the sample tools, bring it back, put it inside it, and then a small rocket was going to take off that was going to go into orbit around Mars. Then another craft was going to come to Mars, meet up with that in Mars orbit, dock with it, take it, and then fire its engines to come back to Earth. And I forget how it was going to come into Earth. It was going to come directly through to Utah, or or someone was going to launch to get that. So it was complicated, and if something's complicated, that means it's also expensive. And NASA has an annual review of their budget, and they have to get their budget approved every year. And happily, Congress has been giving NASA a little bit more money every year, as it should, with inflation and whatnot. Wouldn't you know it? This year, they looked at that project and they said, you're not getting the money for that. And NASA's budget was cut this year. And so they've had to stop certain projects. This was one of them. So right now, there is no plan. Your second part of that, of the protection, believe it or not, there's a person at NASA called the Earth Protection Office. And that's their job, is to make sure that we don't contaminate other planets and that they don't come back and contaminate us. So these whole labs that are, sealed. Anybody remember the Andromeda strain? I love that movie, right? Especially when they burned all the skin off of them, the top layer of their skin. And they have similar things, labs that where these come back, they're all hermetically sealed and opened very, very carefully. We just had a mission come back to an asteroid called Bennu that brought back samples from there. And it was the same thing. You see all these stainless steel glass enclosed cubicles. And hopefully they know what they're doing, and hopefully we'll be protected. Oh, that's that. Do you remember with Apollo, when the poor Apollo astronauts came back, they threw them in a camper, thank you, in a camper for, I don't know, 30 days or something like that. So they grew another head. They were going to send them back or something like that. But anyway, and you had a question, sir? It's nuclear. It's nuclear. The early Mars probes, rovers had, they had these wide decks of solar panels. And the one thing about Mars, it's so dusty that once you start rolling around, the panels start getting covered with dust. Let me tell you an interesting story about that, if I may. So it's just a flat, like a flat board laying out there, and it's, bringing in all the solar energy. And the people who run the rover day after day, they got a gauge that says how much power they got. And they could see day by day, it got less and less and less. They were taking less in. And that's how, the dust is such a problem. One day, they looked at the meter and whoop, it was back up to being high. And they said, what the heck happened? They started looking on their cameras to see, what was in the area. Did they bump into something and it knocked the dust off? Just what the heck was going on? You ready for this? A dust devil came along and blew all the dust off of it. Mars has dust devils. If you don't know what a dust devil is, it's a real mini tornado. We don't get them here much in New Jersey, but they're more prevalent in the Southwest and whatnot. And you go online, you'll see a picture of it. It just looks like the Mr. Clean or whatever that Mighty Dynamo guy was that had a white tornado. And you see pictures of it going through a little league field. All the kids are holding their heads and stuff like that, but it's nothing but dusty. But it can, knock over garbage cans and things like that. So Mars has them, which is kind of surprising because their atmosphere is so thin. But they see them in the distance. And from the orbital craft, they can see the trails they leave. And so luckily, they got cleaned by that. And the thing is, I've talked to them about this when I get on those calls, and it happens like enough where it keeps them alive for a long time. But those two rovers are long gone now. Now they use nuclear power. And actually, it's not nuclear power. It's an RTG, a radioisotope thermal generator. So if you know anything about nuclear energy or radioactive compounds, they decay. And they generate heat when they decay. And heat, using a thermocouple, can be turned into electricity. And today, with the way electronics is, you don't need much juice to keep these things going. And so that's what they have. They have these RTGs on the back that keep them going. Excellent questions, though. Keep them coming. I'm looking for where it is on here. It's right here. It's sticking out the back there. And again, if you remember the Martian, that's what he did. He dug up his RTG so he could stay warm. Okay? All right. So that's it. That's just a quick update on Mars. This is an interesting thing, and this is going to be happening this year. It's a mission to Jupiter. It's called the Europa Clipper. Let me explain. Quick review, okay? How many planets in our solar system now? 8, okay? 8. Okay? 8. Okay? These are the 8 planets, okay? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And I have this chart like this because that's their relative sizes to each other. They're not that close. They never line up like that. And you can see the sun is way over here. You can only see a slice of it. That's how big it is. But that's our solar system, the size relative to the planets. And so clearly, Jupiter is the biggest in our solar system. Well, not only is it the biggest, it's got a heaping lot of moons. It has 95 moons going around it. Some of them very small, but some of them very big. Saturn is the king right now with 146. We only have one. This is a good picture of Jupiter that was taken with space probes. And there's the size difference between Jupiter and Earth. It's quite a lot bigger. And some stats, it's 89,000 miles wide. Earth is about 8,000 miles wide. It's almost 500 million miles away from the sun. One thing interesting about it, it's so big, but somehow it got sped up somewhere, and its day is only 10 hours, 10 of our hours. So it spins really fast. And because of that, the clouds that it has on it, and these clouds are not water vapor clouds, these are methane, ammonia, and all kinds of nasty things. But they form these bands of high-speed gases that go around the Earth, around Jupiter. And so as astronomers, we call them cloud bands. And any backyard telescope, you'll see at least 2 cloud bands when you look up at Jupiter. They won't be these pretty colors. They'll be grayish black, but you'll see cloud bands like that. All right, so that's just a quick review of Jupiter. So this fellow, Galileo, back in the 1600s, the late 1500s, the telescope was invented. Did he invent the telescope? No. He's never laid claim to that, and everybody thinks he did. But somebody, I think, so a Dutchman, I think, actually did it. But anyway, he got wind of it, and he decided, hey, let me put it up to the sky and see the moon and other things in the sky close up. Nobody had ever done that before. So he put together a very rudimentary telescope, and he was looking at Jupiter one night. And in his notebook, this is his actual notebook. And here you see the days, that's the 30th, the 2nd, all the way to the 14th. And so on successive nights, he would look at Jupiter. And when he looked at Jupiter, which is the big circle, he would notice a couple of bright dots near it. And he figured they were background stars. But then a couple of nights later, he looked at it, and those 2 dots were on this side, and one bright dot was there. And so you can see as you go down day after day, every couple of days, these 4, as much as 4 of these bright dots would appear. And that's when he came up with the realization, oh my gosh, these are moons. These are moons around the planet Jupiter, which, you're saying, yeah, so that was astounding back then. They thought the Earth was the center of everything. And so here he is showing orbital motion to something that had never been heard of before. This is what we've done here, right here in New Jersey, looking at Jupiter. And you can see on not so much successive nights, but different times. And you can see 3 moons here, 2 there, 2 there, 3. Hey, here's 3. Where's the 4th one? Right behind it, right? And this one's cool because one of the moons is in between the Jupiter and the sun. And so you got an actually eclipse going. We call this a transit. And so it pretty much matches what Galileo is saying. Now, why 4? Well, I just got done telling you Jupiter has 95 moons. Well, these 4 are big. Here's Earth compared to these 4 moons. These 2 are actually bigger than the Earth. So these are good-sized moons to be with good-sized Jupiter. And they're easy to see. You always see them as dots around Jupiter. Don't worry about the other 90, 91. They're out there, but they're not going to easily be seen from our telescopes. But one of those moons, in fact, I should have read them off to you. I'm sorry. This is Ganymede, Callisto, Europa, and Io. I have to tell you this. A news reporter on TV, something came up about Jupiter, and they listed the moons, and he said, Jupiter's moons are Callisto, Ganymede, Europa, and 10. That's okay. That's okay. So what about it? So Europa, they find fascinating because when Voyager went past Jupiter and took pictures of Europa, this is what it saw. Now, When you're that far away from the sun, everything is cold. You know, water is ice in every form. And Europa, they expect it to look like a cue ball. And instead, it had these brownish lines all over it. Well, that's mysterious. What the heck is causing these brownish lines? Because it's like almost 2,000 miles wide. That's a big moon. Well, we've since had other probes that have gone out to look more closely. And these are super close-ups now. Look how complex this is. They came up with 4 categories. This is called ridged plains. Chaos, I love that one. That's because nothing makes sense. Everything is thrown around in every which way. Craters, which we understand. Even craters will crash onto the moon and make that kind of impression, just like our moon. This one I had to look up. It was called lenticulae, I guess. Lenticulae, thank you. And I said, what the heck is this? And I looked it up, and it's Latin for freckles. And so that's these spots like this. You know, they can't just call them freckles. They got to go to the Latin for this. So these are the 4 different kinds of surface features that are on Europa. What the heck is going on? What's going on with Europa? Well, through what studies they can do from probes that have gone near it, they figure it formed, the 4 moons probably formed the same time Jupiter did. They just condensed out of the same gases and dust that Jupiter formed out of, and everything else did. But they were big enough to become moons of Jupiter. They think it has a metallic core, not a liquid metallic core, but a hard metallic core, more rock, and then ice and water. Water, they think, surrounds the entire moon just under the icy surface. That's amazing. Somebody did some calculations, and you think we're a water planet. Well, our water doesn't go that deep, and it doesn't go all around the Earth. So somebody figured out, you could take all of Earth's water and it would be a size like that. Mars doesn't have any water, so that's why it probably doesn't have any life, at least not now. But all the water in Europa is 2 times the amount of water that we have. You just wouldn't think that. But once you think about the fact that this water is covering the entire moon, that's a lot of water. So since it has this water, that's good. Again, water, life, the way we think. But you need other components for life too, right? You need the chemicals. You need an energy source, as well as water as a medium. Where's it getting an energy source from if there's life underneath the surface of Europa? Well, I'm not saying there is. But what they found is Jupiter is so doggone big that as Europa orbits Jupiter, it gets pulled by its enormous gravity, and it actually stretches Europa back and forth just enough. It's like when you take a piece of metal and start bending it back and forth. It'll break eventually, but it gets warm first. Same type of friction is going on. So they think that this friction, this force of gravity that's on Europa is melting the ice and keeping a water layer underneath. And so if you've got a water layer underneath, now all the hydroscientists come out of the woodwork and they say, oh, okay, well, there's the ocean, and then it gets cold up here, and then it develops cracks, and that's how you get these freckles that pop out like this. And then this kind of thing happens, and that causes the lines and stuff like that. And it's constantly happening, and so it's changing the surface, and that's why they see things happen. So if there is an ocean under the surface of Europa, what could be swimming in it? Right? So wouldn't you just love to land on there, drill a hole, send down a mini submarine and have a look around? Not much light, so there's no energy source there, but where else is it going to get an energy source from? Well, if you look to the Earth, we got these things in our oceans, hydrothermal vents. They call this black smoke, I think, coming up from a vent. And it's way, way down in the ocean. I don't know how many thousands of miles it is, actually. But the thing is, they look around some of these vents where the water is like 300 degrees, and look what they find crawling around. They got creepy crawlers crawling around down there, and there's no light down there either. So if it can happen here, maybe it can happen there. Who knows? But that's the reason for going. They want to understand more about Europa. So they built a craft to do all this wonderful science. They call it the Europa Clipper. I think that's a pretty cool name. And this one's going to be powered by solar panels. They're really huge, as big as a basketball court. And I'm not going to go over all the instruments, but all kinds of things, magnetic sensors here, and the real instruments are on the other side, which I didn't write. So they built this sucker. This is out of JPL in Pasadena, California. They worked on this for a long time. They built everything, the clean room and whatnot. And here's one of the technicians saying, finally, we're done. And this is a whole package of instruments that's going to go. They call it the vault because they want to protect it from the radiation from Jupiter and what out there. It'll fry electronics. So this is what's going. This is what it kind of looks like with you can see some of the workers here. This is the final shipment as it went out to Kennedy. And they flew it out there, and it's at KSC now doing some final tests. And it's scheduled to be launched October of this year. And it's going to go on this thing. Anybody know what this thing is? Elon Musk's SpaceX. This is his Falcon Heavy. This is 3 of his Falcon 9 rockets strapped together. So that's 27 engines. I remember when I first heard him talking about this, I had a 4-H club and I told the kids, what do they teach in science? Keep things simple, right? Because his Falcon 9 had 9 engines. Now he's going to take 3 of them, strap them together. That's 27 engines. But this is why Elon Musk is the genius and I'm just the lecturer. And the thing is, they've launched this, I think, now 5 times and everyone has been successful. Yes, sir. No, they still use RP1, refined kerosene and oxygen. Yeah, that I do admire him for. Once they got to the Block 5 version of Falcon 9, no changes. Leave it alone, it works. And now it's launching Starlink satellites almost every couple of days and landing the booster, which is another topic. I wanted to bring you videos of that, but we'd be here till 10 o'clock. Yes, sir. I think it's going to take a few years. I had this on here and I went right out of my head, but it's going to take a few years. I'm sorry. I do have it next. Excuse me. Sorry. And I'm going to end soon because I see where the time is now. Okay. Take off. And look at this. Look at what it's going to have to do. The purple thing is the Europa Clipper. It took off from Earth. And it's going to need an extra boost. It doesn't have enough rocket power to get it all the way out to Jupiter in time. So it's going to come back and it's going to fly by Earth again, pick up a slingshot gravitational effect from the Earth and throw it back out there. And finally, then it's going to get to Jupiter. And look at this. Where are we? 2027 now, 2028. I think it's 6 years. I think it's going to finally get out there. And that's when it'll get there. And as soon as it gets there, it'll be starting to send back data all the time. But how about that? They do this all the time, by the way, when they're going to the outer planets. They swing the probe that went out to Pluto, New Horizons, they swung by Jupiter. It picked up its gravitational effect. If you're wondering what I'm talking about, is if you ever went roller skating and you wanted to get a whip and you're running along and someone sticks their hand out and then they whip you around, you get boosted. That's what happens with gravity with the planets. So that's what's going to happen. Now, when it gets to Jupiter, now think of this as the Jupiter system. That's all the moons of Jupiter. And there's Jupiter there. But here comes Europa, and it's going to fly right on by, and then it goes, it's going to hit, see Europa there. It's going to come close. Then it has to go way out again and come back in. So it's got this long, complicated arcing that it's going to do, orbiting. It's doing it for 2 reasons. One, it has to because it was going so fast. And the second thing is they want to keep it away from Jupiter a lot because Jupiter's magnetic field and radiation is horrible and it fries things like crazy. So that's the way it's going to be. I'm looking forward to it. I hope I'm around to see this.
How long does the signal take?
It's 15 minutes from Mars to get here. So I'd say for Jupiter, maybe almost an hour. Yeah, they would talk radio waves, everything travels at the speed of light. So what did I say? It's 400 something minus 93. divided by whatever. But I think it's almost an hour. Yeah. So that's Europa Clipper. Hopefully it'll take off okay in October and be on its way, and then we'll get to watch it. Okay. If you want to learn more about this, just go to europa.nasa.gov and you can see the progress that it's made. I'm going to stop now because I think I've run too long. What I'm going to do is flip through this, but this is just about the space station. The space station is doing fine. It ought to be, you hear things about it being decommissioned, but it's going to be around at least until 2030. And then some private industry is going to start adding on to it, which is going to be exciting. The other thing I wanted to talk to you about, you just have to have me back, is about exoplanets, planets around other stars. Just going to give you a quick summary of this. The way they look for planets around stars now is, first of all, they look directly. They put something called a coronagraph in front of the star so it blocks out the light. And then they take pictures over a long, long time. Excuse me. And look at this. This took, I think, seven years to see this planet, a couple of planets going around that star. So that was a successful detection of a planets around other stars. But that takes a long time to do. Here's another one where, again, they black out the star with a coronagraph, and then they looked over here, and here that planet was moving from time to time. So they detected it there. One more, there's the coronagraph, and now you can see a couple of planets here going around. But again, look at the time, years it takes to see all this. So that's not an efficient way of doing things. So what they did is they remembered this, they remembered what's going on here. Right? Doppler effect, okay? Doppler effect happens with sound. We hear it all the time. What's going on is as the train's coming toward you, the sound is getting compressed. And so now you've got a different frequency. And as soon as it passes you, now it's stretched. So it drops down to that other frequency, Doppler effect, okay? Well, thing is, some smart people realize that light also can do that. If you put white light through a prism, you get all the different colors that come out, and those colors are different frequencies along a certain wavelength. And so if you, this led rise to something called the spectrograph. And so with that, if you illuminate an object, you can see what it's made out of just by looking at its spectrum. And the spectrum is always running from red to blue, but you see these black lines that go down? That's elements or compounds in the object that are missing or it's being pulled out of it. And so by looking at the pattern, you can tell what element it is or what composition it is. And they do this all the time. But somebody decided to look at a star like this. And they found that, what's going on? They said sometimes when they look at the star, it's one way. Another time they look at the star and it's shifted. This is called blue shift. This is called red shift when it goes that way. So what's coming and going here, right? What's going on? Well, again, planetary scientists figured it out that that's a planet going around a star. Now, if you ever see the hammer throw in the Olympics, right? When the person is moving around and around to throw this hammer and then lets go of it. But if you look just at his body is going back and forth to counter the force of the hammer that he's throwing. And so that's what the star will do. All stars, if they have planets going around them, they wobble. Our star wobbles. All stars that have planets wobble. And so the thing is, if it happens to be in the direction of where we're looking, that star is going to be going forward and backward to you. Minuscule, minuscule. But if it's going forward and backward to you, that's the Doppler effect. And so the light coming is being condensed this way and expanded the other way. And so you get a red shift or a blue shift. Red shift if it's going away from you, blue if it's coming toward you. Amazing, isn't it? And so they started looking at stars with the spectrographs, and they found tons of stars that were doing that. And that's how they detected planets. One more. Then with photo cells that you have in your cameras and everywhere, got to be CCD, no, is that a CCD? A type of chips. They're so sensitive to light that they built a big one, put it on a telescope and put it into space to look at a whole bunch of stars. And they actually can detect a planet going in front of a star. And they saw that the light dropped. Can't see the planet, but they saw this, it dropped. And then all of a sudden they saw another one that dropped a little bit bigger. Must have been a bigger planet. And then they kept watching that star and it was rhythmic. It was every so many years, every so many months. And they detect there's a planet or planets around those stars. And so these are the two methods that they've been mainly using now. That's called the transit method. And that's the radial velocity is the back and forth one. But those are the two main things that they've been looking for planets. And look at that number. 5,630 planets have been found or detected around other stars. And this is just in the last 10 years. 5,630. So scientists did not know until this started if there were planets around other stars. And so now they say for every star, there's a planet or even more planets. So there's lots of planets out there. And I will promise you that I will end now. And I'll end with this. I got to skip through all this wonderful, cool stuff. Oh, that's our observatory in Highbridge, by the way. Website njaa.org. Come out to us on Saturday nights. That's me. But I'm going to end with 5 slides that's going to put you in your place in the universe. I love to end this way. I just told you, right? That's our solar system. You know what it is. You understand, right? And the planets are going around the sun. There's other things. There's asteroids, meteoroids, and comets. But if I took all the planets, took all the rings away from, took all the moons and everything away from, just kind of like made them out of Play-Doh and put them on a table, it would look like that. Okay? Here's Earth way down here. There's tiny Mercury, Uranus, Neptune, Jupiter, Saturn. Makes sense, right? What's missing? No. Stop that. The sun. Thank you. Okay, here comes the sun, folks. All right, there's the sun. No matter how many times I tell you 860,000 miles and things like that, doesn't mean anything to us, right? Put it on a table with the other planets and whoa. Now you realize how tiny we're. Look, Earth is like my laser dot. So that's our sun, which is our star. By the way, sun is the name of our stars, just like there's Polaris, Aldebaran, Arcturus. So don't ever say, wow, look at all those suns out there. That's like saying that's all, look at all the Johnnies in the playground. No, that's we have a star. Our star is named the sun. Do we think our star is the biggest star around? No. There's our sun. This is Sirius, Pollux, Arcturus. He's rolling in the night sky. Keep an eye on Arcturus here. Arcturus is now down here. Rigel, Aldebaran, Betelgeuse, and Antares. They're different colors because they're different temperature levels on them. So that's just to put things into perspective for you. Lastly, if you're ever in a nice place like out west or in Pennsylvania, someplace where you can really, really true see a night sky with no moon and no light pollution, you may get to see this, which is one arm of our galaxy. And you see beautiful amounts of stars. And this is what we think our galaxy looks like from the top looking down. We think we're a dot somewhere in here. But our galaxy contains hundreds of billions of stars. Hundreds of billions of stars. You hear some scientists say 400, 300, 200. I don't care. 100 billion is a lot of stars. So hundreds of billions of stars is what I say. Are we the only galaxy out there? Nope. Here's 6 examples of real pictures of galaxies. Here's 2 galaxies merging, but they come in all different shapes and sizes. Each one of them has hundreds of billions of stars. So they took the Webb telescope and they said, you know what? Let's point it at one little tiny spot of the sky. And actually, it's the width of a sand grain in your outstretched arm. A tiny little sand grain. That's the spot of the sky that Webb looked at. And it looked at it for 12.5 hours. If you know photography, right, the longer the exposure, the more you can see. So a tiny little speck of sand outstretched your arm for 12 and a half hours, and they look at what they got, and they got that. Every little smudge you see here, every little smudge is a galaxy. So in that little tiny speck of sand is hundreds of galaxies just there. Each galaxy, hundreds of billions of stars. So guess how many galaxies there are, folks? Hundreds of billions of galaxies. Wow. If that doesn't leave you with a good sign off for tonight, I don't know what does. So with that, I say thank you, and thank you for taking the time. I have a question here. Yeah, I could. I'm not gonna hog tie you folks to your seats for that. I will answer your question. Those who want to stay and listen. Yes?
You live his life, so.
With all those numbers, gotta be. Yeah. Now, I believe it's out there, not in somebody's backyard in Arkansas. Okay? So, yeah, all these things you see on TV. I grew up with science fiction. I loved science fiction. Flying saucers, all that stuff. Oh, it's so cool. But now that I know more, no, sorry. Skinwalker Ranch or whatever things. No. Okay. Out there, yes. Has to. Mathematically, it has to be. Thank you.